We have already mentioned that MAD is more robust than standard deviation or variance. Now, we know exactly why that is, but let's just quickly have a feel for that using some actual computation where we really introduce some outlier and see that SD or variance gets affected a lot, whereas MAD hardly is affected. So let's go to the lab to see that. In this video, we are going to compare MAD and standard deviation in terms of their robustness. So I have this data set. How many? That starts from row 2, goes on up to row 101, so 100 numbers. I want to compute both their MAD and standard deviation. So let's start by computing MAD. LibreOffice doesn't have any MAD computation, so I will just quickly do it. I will first create x minus median, an absolute value of that, a column headed with this. So the way I will do it is, I will write equality, then this minus, well, I need to put the absolute value first, of course, I forgot to do that, abs, then I write median of, well, I am going to write A2 to A101. Now my plan is to just drag this all over the place. So if I drag, let me just show you the mistake. You can see that this has changed to A3 to A102, which is not what I want. I want this to remain from 2 to 101. So instead, I shall modify this line a little bit. I will put a dollar sign before the 2 and a dollar sign before the 101 so that they remain fixed. Now if I drag, you can see that this has changed to A3, but these are fixed at 2 and 101 respectively. So now I am in a position to drag it all over up to 100 things. Now I feel lazy. I do not really want to drag the thing all the way up to 101. So I will type it here. I have B2 colon B101 and I hit enter. So everything gets selected. Now I want to have the effect of dragging this. Drag starts with D. So I will hit Control D. D for drag. And it has the same effect as dragging it all the way. So I can just show that yes, it has gone up to 101. Now MAD is median of all these things. So MAD, I will write this is median of B2 to B101. So I get my MAD value this. And for comparison, I will also create my standard deviations, ST, that is ST of same B2 to B101. Now, whenever I change these numbers will change. So MAD and ST will also change. So they are some kind of live values. So I will just call them current, because I'm going to change my data to test robustness. And I will also keep the old values, the values that you see now. So I will just copy, Control C. Now, instead of just pasting, in which case the formula will get pasted, I will right click. I'm right clicking and I will go to paste special. From that, I will go to unformatted text and hit OK. So you see the same values, but when I change my data here, these numbers will change in a live fashion, but they will remain static as benchmark values. Okay, now let's come to which value? Suppose I come to this value. Someone typed it like 100.27. Now let's see what happens if he forgot that point. So he typed by mistake this huge number 10027. I hit enter. The moment I hit enter, you see SD jumped up like crazy. It was zero point 0.7 and it became 992 point whatever. MAD remains rock solid. It just stayed wherever it was. Now, such a mistake, just forgetting a point, is a very common mistake. In fact, you can change some other things also. Suppose here also I have forgotten the point. And you see, this is going up. MAD has gone up, but only very slightly. That is why we say MAD is robust.